Welcome friends to my YouTube channel Nous. This is the third video of the series of video that I'm making on solid design principles. So first two videos talking about single responsibility principle and open closed principle. So in case you guys have not seen those videos, I would suggest you to go back and watch those videos as well. In this video, in today's session, we are going to talk about Liskov substitution principle. So let's start with its official description. So as you can see that I have highlighted some words over here in this slide. The first is warning, and then the warning. What this warning says is the official description of the Liskov substitution principle sounds rather technical and hard to understand. Okay. So it's fine if you are not getting this official description. Okay. Please bear with me, and I'll make sure by the end of this video you guys should understand everything about Liskov substitution principle. Okay. So let's begin with the official description. Uh, if for each object O1 of type S, there is an object O2 of type T, such that for all program P defined in terms of T, the behavior of P is unchanged when O1 is substituted for O2. Then S is a subtype of T. Okay. As I already told you, it's very hard to understand. Okay? The official description is very technical and hard to understand. So in next slide, what I have done is I have explained the same thing in easy words. So let's see what it says in my words. What it's saying is when a class A depends on another abstract class or interface X, this can be abstract class or interface, okay? Any subtype of X should be entirely valid in the same context. That is, implementations can be substituted. Okay. And the same thing can be said in other words also. Let's see what is that. The Liskov substitution principle states that subtypes of a class should be able to be used interchangeably, where an instance of the class A is expected. Okay, so what actually it is trying to say is, suppose you have a class A and you have an interface X. Okay, and there are n number of implementation of X or subtype of X. Okay, say it's X1, X2, X3. There are three subtypes of interface X. And class A is dependent on interface X. You can either say it's dependent on interface X or one of its subtypes like X1, X2, X3. So according to the Liskov substitution principle, if you have designed your components, means classes and interfaces, in a way where class A can use any of the subtype of X, like it can use X1, it can use X2 or X3, means without any difficulty. Means suppose initially it was using X1 and then in future you replace that X1 with X2. It should not give you any error. Even you should not be needed to make any changes in the existing code. Okay. This swapping between subtypes or implementations of interface should be done without making any changes. Okay. If your components are following Liskov substitution principle, if it is not following, then obviously it will not work in that way. When you will interchange your implementations, then you might do some changes in your code. So let's try to understand it through an example. Okay. So what I will do, I will open the slide and my Eclipse both parallelly. Okay, so for initially what we are going to do is I will create some classes interfaces, though I already have created them just to save some time. Okay, so let me show you the classing interfaces. Okay, so when a class A depends on according to this definition, we have a class A that is dependent on another abstract class or X. Okay, so first of all, let me show you the interface. We have this interface X, what is highlighted in the slide. In the Eclipse, we are saying that as data repository. We have an interface called data repository. This interface is having two abstract methods. Void persist data that takes object as its input. And the second method is read data that takes a long and returns the object. Okay. And then as it says, any subtype of X should be entirely valid in the same context. So we will have to create subtype of this interface also, right? So in this example, currently we have created two subtypes of this interface. First one is called customer repository. You see that customer repository is implementing data repository, this interface. Yeah. And because this is implementing this interface, so this class will have to override these two methods that is coming from this interface, right? Persist data and read data. So we have overridden these two methods here in this class. However, I have not provided the business logic because the objective of this video is not to explain you how to write logic to persist data or read data from the database. Okay. So although I have given the to-do list, if you want, you can write a logic to store the data in the database and read the data from the database. For this particular example, I have just written the system.out.println just to make sure that when I'm invoking these methods, whether these methods are actually getting invoked or not. So this persist data is printing data persisted successfully, and read data is printing data returned successfully. Okay. So this is one implementation of this data repository. We have another implementation called historic stock price repository. This class is also implementing data repository, the same interface. And because this is implementing this interface, we'll have to override these two methods. Okay. However, in this particular class, this particular method was not required because this is dealing with historic data. Okay. So data is already stored in the database. This class is, the data is read only. This class is dealing with the data that is read only. Okay. In practical, this method is not required in this class, but we'll have to override it because we are implementing this data repository in this class. And because this class, however, we have overridden it, but we need to throw some exception from this persist data because this class is dealing with the data that is read only. So we are throwing this exception called runtime exception, data is read only. Okay. So we have this interface, the slide shades interface X and any subtype of X. So this is X. Okay, this is X, and we have two subtype of X, that is this one and this one, customer repository and historic repository. Then it says when a class A depends on another abstract class or abstract X. So we need to create this class A also, right? So this class A is represented by this class in this example, data service. Okay. Data service is the class that is dependent on this interface data repository. So suppose you comment this dependency, then it will start giving you error, right? Because this data service is dealing with persistence of data and reading data from the database. With the help of this class, it cannot perform the persistence and reading the data on its own. It needs this class because we have written the logic inside this data repository to persist the data and to read the data. Okay. So this data service means this class A is dependent on this interface X. Okay. So according to the Liskov principle, if this whole design, the classes and components that I have talked about till now, if this class follows Liskov principle, then we should be able to interchange these two interfaces. These two interfaces, custom repository interface and these two subtypes of interfaces, custom repository or historic data repository. So to prove that or to check that whether we are able to swap or interchange these subtypes or not, we have written a client. We have a main method in this client. So we need to invoke these methods to check whether we are able to interchange these subtypes or not. Okay. So what I have done is I have created an object of this class data service. And you see in data service, we have a constructor. This constructor that is taking an object of data repository, right? So this is a reference of the interface or the parent, you can say. This is the parent, right? So the reference of parent can hold the object of subtypes, right? So that's why I have used the reference of parent over here. But it's client's responsibility to send the actual subtype to this data service class. So I have created an object of data service and we are passing this chat repository, customer repository class object to this object. Okay. And then we are using this object, we are calling persist data and read data. So let's see its output. Let's try to run it and let's see its output. So it's giving you expected output, right? We had written the data persisted successfully in persist data method and data returned successfully in read data method, right? So it's giving these two outputs because in this interface you see these two methods, right? Persist data and read data. And it is giving the output of these two methods. So it's working fine. Now, if this whole design is following Liskov substitution principle, then we should be able to replace this subtype with this subtype. This is another subtype, like this is the first subtype of this interface. This is the second subtype, historic stock price repository. So if it is following the Liskov substitution principle, so suppose I'm replacing it with the other subtype. Okay. Comment this out as well. So see, now I have the same object data service, object of this class. And now initially we provided this reference, this class object, customer repository object to this reference, right? Now we are providing historic stock price repository object to this reference using this client. See, data service, new data service. Now, initially we were passing customer repository object. Now we are passing historic stock price repository. We are interchanging these subtypes now. So if the whole design is following Liskov, then we should get the same kind of output. So let's run it. See, if throwing this data is read only. Why? Because we are calling this persist data, and in historic, this persist data is returning runtime exception. So this is not following, this whole design is not following Liskov substitute principle. That's why we are not able to swap out these subtypes or implementations of this interface because we are not following Liskov. So the one solution is you come here and sorry, in this class you come here and you check using if else statement if if data repository you can provide some fixes to these again, like here in this class, if this data repository instance of this class, external repository class. Then you will do this else do nothing or something like, or you can print some message over here like this. Since it is read only data, no need to persist. Something like this. This is a fix, okay? So now run it. This is a fix, but it's not still it's not following Liskov substitute principle. See, now at least you are not getting that exception. It's printing that since it's a read only data, no need to persist. And data returned successfully for that second method call. For this method call, it's giving you an information that because it's for this method, it's printing this message for you. And for this method call, it's giving you this response, data returned successfully, right? But it is still not following the Liskov substitutes principle. In fact, this is this kind of a statement. This is when you use instance of and something like that. This is a sign. This is a sign of Lisp not being followed. Whenever you see this kind of call, statement like instance of particular implementation, it means you are going to break, means this particular design is not following the Liskov substitution principle. Okay. So this is let's roll it back. We don't need this fix and all. Okay. Now we will try to refactor our codes, all these classes, wherever it is required. We will refactor it, and we will try to follow Liskov substitution principle in our design, so that we should be able to interchange these two subtypes in this class. Okay. So let's try to do that. I already have done some refactors. I'll show you how to do that. So see, first thing that we need to do is, because see, as I told you, in this historic stock price repository, this method was not intended. Okay. Only this method was intended, but still we implementing this data repository. So the first thing that we are going to do is let's create two interfaces instead of this one interface, let's create two interfaces. One will have this method and another will have this method. Okay, so let's create it. So see, I have created this read data repository. In read data repository, we have just one method, that is read data. Similarly, I have created another interface, that is write data repository, and in this method as well we have only one abstract method, that is persist data. Means we have divided these two activities into two different interfaces. Okay, read and write. Now since the customer repository, these subtypes need both of these methods, so now instead of implementing this class, let's comment this out. This class will implement both the new interfaces, read data repository as well as write, because this class is dealing with both persistence and reading of data from the database. Okay, so this read from this interface, read data JP repository, it is getting this method and we are providing overriding this method. And from this interface, it's getting this method and we are providing the implementation for that method as well. Okay, so this is done. Now go back to another subtype, that is historic stock price repository. As I told you that this method was not needed, but we had to override this method because we had implemented this interface. So this is a wrong design. Okay, just comment this out. And now this class will implement only read data interface, read data repository interface. Okay, and because this is implementing just one interface and in this interface we have only one method, so we need not to write this method, right? So we just comment this out. Okay, so now this class is implementing just one read method. Now in data service, the class A that is dependent on these interfaces, data service class, initially it was dependent on this interface. Now it will depend on these two interfaces. Private read data repository. Okay, and write. So now this class will depend on these two interfaces. So we'll have to create a new constructor as well. Okay, so comment out the existing constructor and let's generate the new one. Generate constructor using fields. Yeah. Okay. So I created a new constructor that initializes both of these interface references. Okay. Now for persistence we need to use this write data because this method is called persist data method, right? So for persistence, we'll call persist method using this reference, and read data will call from this reference. Okay. Now we have these two interfaces, so we will have to provide the implementations as well, right? So we have provided the implementations in where in customer repository that implements both the interfaces, and stock price repository, we have provided the implementation for read data because it is implementing just the read data repository interface. Okay. Now let's see what is needed in client. So first of all, this constructor will not work because now the constructor takes two parameters. In data service, the constructor is taking two parameters, right? So we'll have to create object of these two subclasses, customer repository as well as historic data repository. And first it takes read data. Okay. So just comment this out, create a new object using new constructor data service. Data service equal to new data service. Okay. So now see, we are passing both these subtypes to this particular class because this class is dependent on both of these interfaces. Okay. Now let's try to run it and see the output. See, it is doing both the thing. It is persisting the data as well as it is returning the object as well. In both of these methods, what I have done, I have just printed the sysout, right? So both the statements are getting printed. So it's working fine. So now, according to the Liskov principle, we should be able to interchange the implementations, right? That's what Liskov substitute principle says, right? Liskov substitute principle. We should be able to interchange the implementations or subtypes right without any change or difficulty. Okay. This is what Liskov substitution principle says. So see, these two principles are our mandatory interfaces, mandatory implementations that we need because this class, data service class, is expecting the implementation of these two interfaces. So we won't be able to interchange these two for now because this is dependent on both the interfaces. So what we can do is we can provide one or more implementation to any of these two interfaces, means to read data repository interface to this interface or to this interface. Both these interfaces currently having just one and one subtypes. So let's add some more subtypes to any of these two interfaces or both of these two interfaces. So just to understand, I have already created one more implementation for this interface. Okay. So, and the name is this historic stock price repository 2. This is the first one, historic stock price repository. Let's rename it to refactor rename. Let's make it 1. Okay. Okay. So now, if you see, let's close everything just to avoid confusion. Close others. So this implementation, write data repository, is having two subtypes now. First one is this historic price repository 1, and the second one is historic price repository 2. If you see both the classes implementing read data repository. This one is also implementing read data repository. Another one is also implementing read data repository. So now this interface is having two implementations. Now open this client. Okay. So now according to Lisp, we should be able to interchange the implementations without any change or difficulty. Okay. So initially we were using this interface. Now let's replace it with the new implementation that we created. What is the new implementation? This historic stock price repository 2, right? This is the one, this is the second one. Make it 2. Now you simply replace this with this. You replace this with the new one. So initially we were passing this customer repository, say this one. Now we'll pass this one, the new one. See, now we are passing the second implementation, right? Now let's run the code. So even you can comment this out, this previous one out, because this is not needed anymore, right? So I commented this one and now run this piece of code. See, you are getting the same response, right? You swap out the implementation, existing implementation with the new implementation. This is the beauty of Lisp. Now our design, this whole design is following the Liskov substitution principle. Now even you want to change again, you comment this out, you uncomment this out, and you use this one again and run it again. You'll get the same response. See, without any difficulty, you are just swapping out implementations. You are using you are using historic stock price repository 1, sometimes you are using historic stock price repository 2. So this is all about Liskov substitution principle. So when you are designing, if your design is following Liskov substitution principle, you should be able to use your subtypes or implementations interchangeably. You can easily swap out between these implementations. Okay. I hope you guys understood the concept of Liskov substitution principle with help of this example. If you have any doubt or question, please put your doubts and questions into the comments. I'll try to answer those questions. And even if you have some suggestion for me, please provide your suggestions. I'll try to I try to follow your suggestions in my coming videos. I think that's it from today. Thank you very much, guys. One more thing, if you like my videos, please do click on like button and please subscribe my channel. Thank you very much. Bye bye. Have a nice day.